Download this code from codegive.com, link in the description below. OK, let's dive deep into the world of bar charts and the ethical considerations of data presentation, specifically when dealing with truncated, or non-zero based, axes. This tutorial will cover 1. The importance of accurate data visualization * why truthful representation matters. 2. Understanding truncated bar charts * what they are and how they can mislead. 3. Why truncated axes are used, and sometimes abused, exploring the motivations. 4. Identifying and spotting deceptive truncated bars * practical tips. 5. Ethical considerations * when, if ever, are truncated bars acceptable? 6. Alternative visualization techniques * methods to avoid deception and still highlight key differences. 7. Code examples, Python with matplotlib / seaborn demonstrating how to create accurate and informative bar charts and how to responsibly use alternatives like slope charts or difference highlighting. 8. Best practices for data visualization * guidelines for responsible and transparent data communication. 1. The importance of accurate data visualization ***. Data visualization is a powerful tool for conveying information. However, with great power comes great responsibility. Visualizations should accurately represent the underlying data and avoid misleading interpretations. A poorly designed chart can distort the truth, leading to incorrect conclusions and flawed decisions. Accurate visualizations foster trust, promote understanding, and enable better decision-making. Conversely, deceptive visualizations can erode trust and lead to mistrust. 2. Understanding truncated bar charts ***. A truncated bar chart is a bar chart where the y-axis, or x-axis, if the bars are horizontal, does not start at 0. Instead, the axis begins at a higher value. How they mislead ***. Exaggerated differences * truncated axes amplify the visual difference between bars. Small differences in data values appear much larger, giving a misleading impression of the magnitude of change or variation. This is the core problem we're addressing. Distorted proportions * the lengths of the bars no longer directly correspond to the actual proportions of the data they represent. Because the starting point isn't 0, the visual ratio between bars is skewed. Manipulation of perception * truncated charts are often used intentionally to make a particular point seem more significant than it actually is. This is a common tactic in marketing, politics, and other fields where influencing opinion is a primary goal. 3. Why truncated axes are used, and sometimes abused. Highlighting small differences, potentially justifiable in some cases, the absolute values of the data are less important than the change or difference between data points. If the values are all very high, starting the axis at 0 might compress the bars so much that any variation becomes visually imperceptible. This can be acceptable, but must be done with extreme caution and with clear labeling / annotation to avoid misinterpretation. Saving space * starting the axis closer to the data can sometimes make better use of the available space on a graph, especially if the data range is narrow. Deliberate deception, unethical. The most common, and most problematic, reason is to exaggerate differences and mislead the audience. This is often done when the actual differences are small or insignificant, but the presenter wants to create a more dramatic effect. Laziness or lack of understanding * sometimes, truncated axes are used simply because the person creating the chart isn't aware of the potential for distortion or isn't paying close attention to best practices. 4. Identifying and spotting deceptive truncated bars ***. Here's how to detect if a bar chart might be intentionally misleading. Check the axis **. This is the most important step. Always examine the y-axis, or x-axis for horizontal bars, to see where it begins. If it doesn't start at 0, be suspicious. Asterisk look for warnings or annotations. Asterisk sometimes, authors will try to mitigate the effect by including a disclaimer or a broken axis symbol, a zigzag line, to indicate that the axis is truncated. However, a warning doesn't automatically excuse a misleading visualization. Asterisk consider the context. Asterisk what is the presenter trying to communicate? Do the conclusions drawn from the chart seem overly dramatic or sensationalized? Is there a vested interest in presenting the data in a particular way? Asterisk compare to other visualizations. Asterisk if possible, find other visualizations of the same data. Do they present a different picture? Asterisk check the data values. Asterisk if you have access to the underlying data, examine the actual values and calculate the percentage changes or absolute differences. Do they align with the visual impression created by the chart? 5. Ethical considerations. Asterisk. Generally, always start your bar charts at 0. There are very few exceptions where truncating the y-axis is ethically justifiable. Asterisk transparency is key. Asterisk if you must use a truncated axis, be extremely transparent about it. Asterisk use a prominent axis break symbol, example a zigzag line. Asterisk clearly label the axis with the starting value. Asterisk add a footnote or caption explaining why the axis is truncated and acknowledging the potential for misinterpretation. Asterisk consider alternatives. Asterisk before resorting to a truncated axis, explore other visualization techniques that can effectively highlight differences without distortion. Asterisk be prepared to defend your choice. Asterisk if you choose to use a truncated axis, be prepared to explain your reasoning and demonstrate that you've taken steps to mitigate any potential for misinterpretation. 6. Alternative visualization techniques. If your goal is to highlight small differences without misleading your audience, consider these alternatives to truncated bar charts. Line charts. Excellent for showing trends over time. A line chart can often more effectively display small changes without exaggerating them. However, they are best suited for continuous data. Slope charts. Specifically designed to show the change between 2 points in time or categories. They directly visualize the magnitude and direction of change. Difference highlighting in bar charts. Instead of truncating the axis, you can focus on visually representing the difference between the bars. For example, you could highlight the area between the bars or use a separate chart to show the percentage change. This keeps the zero baseline while still emphasizing the changes. Focus on percentages/ratios. Instead of displaying raw values, show percentages or ratios, which can provide a more meaningful comparison. Small multiples. Create a series of small charts, each showing a different subset of the data or a different aspect of the analysis. This can help to reveal patterns and relationships that might be obscured by a single, complex chart. Dot plots. Use dots instead of bars to represent data values. This can be particularly effective when comparing values across multiple categories. 7. Code examples, Python with matplotlib/seaborn. Here are examples demonstrating how to create both misleading truncated bar charts and more responsible alternatives. Explanation of the code. Basic bar chart. The first two examples create a simple bar chart, one with a truncated y-axis, intentionally misleading, and the other with the y-axis starting at 0, accurate. Slope chart. This example uses plt.plot to create lines connecting the sales figures for each product in the previous and current periods. It visualizes the change in sales for each product. Clear labels are added for readability. Asterisk difference highlighting bar chart asterisk this example calculates the difference of each sales figure from the mean sales. Then, it uses conditional plt.bar, calls to color the portions of the bar above the mean green and those below the mean red. A horizontal line represents the mean. A seaborn version illustrates how this can be done with seaborn as well. Asterisk dual bar chart for percent change asterisk the last chart superimposes a bar chart showing current sales, with another bar chart that sits on top of the first chart, displaying the percent change. This allows for direct comparison without misleading the underlying data. 8. Best practices for data visualization asterisk asterisk. Asterisk always start bar charts at 0 asterisk unless you have a very compelling and transparent reason not to. Asterisk label axes clearly and accurately asterisk include units of measurement. Asterisk provide context asterisk explain the data and its implications. Don't assume your audience will understand the visualization without guidance. Asterisk choose the right visualization for your data asterisk not all data is best represented by a bar chart. Consider alternatives like line charts, scatter plots, or histograms. Asterisk avoid chart junk asterisk remove unnecessary visual elements that can distract from the data. Asterisk be aware of color asterisk use color effectively to highlight important information, but avoid using too many colors or colors that are difficult to distinguish. Asterisk proofread carefully asterisk ensure that all labels, titles, and annotations are accurate and free of errors. Asterisk get feedback asterisk ask others to review your visualizations to ensure they are clear, accurate, and easy to understand. Asterisk prioritize honesty and transparency asterisk your goal should be to accurately represent the data and empower your audience to make informed decisions. In summary asterisk. Truncated bar charts can be a powerful tool for deception. While there might be rare cases where they're justifiable, it's crucial to be aware of their potential for distortion and to prioritize honesty and transparency in your data visualizations. Explore alternative visualization techniques that can highlight key differences without misleading your audience. Always strive to create visualizations that are clear, accurate, and informative. By following these guidelines, you can ensure that your visualizations are both effective and ethical. Remember to use the code examples as a starting point and adapt them to your specific data and goals.